Hello guys, welcome once more to another video in our YouTube channel. So in this video of today, we are going to be looking at integration. So we are basically going to be integrating a trigonometric function which is the integral of dx on 1 minus sine x. So that is what we are going to be looking at. So I'm going to go through a single method in this video, and in the next video I'm going to introduce a different method. Remember that definite integrals always result to different answers, but when simplified we always get one answer at the end. So regardless your method, if it is rightly used, you are correct. So what I'm going to do is I'm going to kind of do what we call multiply top and bottom by the conjugate of the denominator. Now my denominator is 1 minus sine x. So what I'll do is that to the same function, I'm going to multiply its numerator and its denominator by 1 plus sine x. So what I'm going to do is I'm going to put here 1 plus sine x, and then here I'm also going to put 1 plus sine x. Then don't forget the dx because you're integrating with respect to x. Now my numerator is going to stay as 1 plus sine x. Okay, what is now going to change is my denominator, because this denominator now resembles the difference of two squares. So if you look at 1 minus sine x times 1 plus sine x, when you expand you're going to have 1 minus sine squared x, and I'm integrating with respect to x. Alright, so from there you realize that 1 minus sine squared x is just giving us cos squared x. So here we are going to have the integral of, here we are going to have cos squared x, and the numerator we are still going to have 1 plus sine x. Now since the terms in the numerator have a common denominator, we can now separate the integral into the integral of 1 over cos squared x dx, then plus the integral of sine x divided by cos squared x dx. Alright, now this is now very easy to integrate, because you just realize that if I integrate 1 over cos squared x, now 1 over cos squared x is the same as sec squared x, and the integral of sec squared x is just tan x, because if I differentiate tan x I'm going to have sec squared x. Now in this other integral you actually realize that if I differentiate cos, I'm going to have sine, actually negative sign. So this is going to be kind of minus. Alright, so minus, let me try to do the substitution so that you guys see perfectly what I'm saying. So I'm doing the substitution for this integral. Okay, so I'm going to let u to be equal to cos x, because if I differentiate cos x I'm going to have negative sine x. So du is going to give me negative sine x dx. But you see that in the integral we have sine x dx instead. So sine x dx is equal to negative du, alright, because this is sine x and dx, alright. So now this integral will just be equal to, now we said that this portion is just giving us tan x, okay. Then now in the place of sine x dx we are going to replace it with negative du, alright. So we are going to put the negative outside, then we are going to have du divided by u squared, alright. And du divided by u squared is just u raised to the power negative 2 du. Now it is easier for us to integrate, so we are going to have tan x minus, now if I integrate u to the negative 2, I'm going to have u to the power negative 2 plus 1, which is negative 1, then divided by the negative 1. Then we need to add the constant of integration. Okay, so at the end of the day we are just going to have equal to tan x minus, no, it's now going to be plus. Alright, now u to the negative 1 is 1 over u, and 1 over u is actually 1 divided by cos x, alright, then plus a constant of integration. But what is 1 over cos x? 1 over cos x is equal to the secant of x. So at the end of the day we can conclude that this integral is equal to tan x plus the second of x, then plus a constant of integration. So thank you very much for watching. We have come to the end of this video. Like, share and subscribe to the YouTube channel. See you guys in the next video.